Hi, it's Joe Justice, and here's my analysis of the Ford F-150 production assembly system for the Lightning. Now, this part's already interesting. This is an old school hot rod balancing tactic where the chassis, in this case, it's just the body and the ladder of the ladder frame, is being balanced side to side. This is above and beyond how a traditional pickup truck is made currently with this level of side-to-side balancing. So already impressive, but also bewildering. Something much cooler might be going on here than I'm noticing, but why the chassis would be side-to-side balanced like an old school hot rod, I'm not entirely sure. But what is exciting is this is above and beyond traditional current SUV or pickup truck manufacturing. Now, much more interesting is the battery pack. You can see 50% of the upper floor is an entire second floor for a second row of cells. This pack is massive. Now, how much it's loaded, we can't see here from this video. What that might mean is a huge area to expand additional cells across that pack without changing the form factor. Now, much more interesting, I think, is these interface points. They're standard interface points that looks like they could last many generations of packs if Ford chooses to be able to swap upgraded packs back and forth into vehicles that they haven't even thought of yet. You can see there's 6 hard points together, and they have automated integration. Now, here in the background, this is simply a cart that delivers this battery pack elsewhere onto the production line. And unfortunately, it looks like it's following a single pre-mapped magnetic strip in the ground. So it's not dynamically being called to an agile assembly operation. But even so, something very good and inspiring is happening here. This is an automated integration test. This robot, with its 6 hard points, is setting the battery pack on an integration test. And we know at this stage, if whatever battery pack they may switch to in the future is still meeting the current interface. Now, whether they're going to be agile about the pack or not and innovate it rapidly, we don't know that yet from this video. What we can see is it looks like there's massive room for growth within the same interface, and it looks like there is an automated interface test, which is what you'd want for future rate of change. And now, unfortunately, you can see that the truck is still body on frame. That uses more metal, which costs more, and weighs more, which is less safe for pedestrians and transmits even more energy into other vehicles. In a crash, it's less safe to the other vehicle, and potentially even less safe to your own vehicle, depending on what deforms back at you with all of that mass involved in the crash, creating greater crash energy. That's less optimum than unibody, and even less optimum again than exoskeleton, like Cybertruck is intending to use. And we don't see any giga castings, mega castings, anything like that. It's absolutely a traditional pickup truck ladder frame, but with a battery pack integrated, which is awesome, a massive battery pack integrated. Now, next, we can see a lot of floppy wire. Now, the problem with floppy wire is it needs to be installed by humans, not robots. And that's exactly what we see, is lots and lots of humans on this part of the manufacturing floor. Tesla has replaced most wiring with rigid wire packs, which can be robotically installed. It looks like at this stage, the Ford F-150 Lightning line is not that advanced. It's still using floppy wires. Now, there are screens on both sides, actually all around the manufacturing line. And in a few areas of the videos, we can read them clearly. I'll see if I can stop on one. But I'll say now, they show takt time for old school single one-piece continuous flow, instead of digital self-management to incorporate change at any time. The most I've been able to make out on these monitors is the VIN number of the build and the configuration of set configurations. as opposed to dynamically reducing the need for management and accelerating employee learn rate for a faster pace of innovation on the line and design on the line. I don't see any evidence of that. There's automated smart carts, but they appear to be on fixed magnetic tracks. You can see the shade here on the ground. They appear to be on fixed magnetic tracks as opposed to being dynamically called. Behind, you see stamped metal non-structural body on frame tops as opposed to gigacasting, megacasting, or exoskeleton. Traditional manufacturing, it doesn't look like there's a dramatic innovation that I'm seeing here. That said, I'm open to being wrong. I mean, I worked at Tesla and was shocked by what I saw there, but I've not worked on this line. Now, it looks like you have humans doing overhead work, again, floppy wires in the interior, and then snap-in body panels that aren't roboticized, partly because you don't have an entire glass roof that can do optimized robotic installs on any surface. Over shoulder operations are some of the highest injury prone operations. You have to pay extra because of risk, etc. You'd want to avoid these, and we're still seeing lots of those. There's actually several areas in the video we see this, over shoulder operations manually done. Floppy wire interior needs human installers. Interior still is plastic pin attached. Yeah, overhead work, you can see the floppy wires hanging down. Traditional automotive, plastic snap-in construction. Again, not heavily roboticized due to a full glass roof. Most positions we've seen so far are only 1 or 2 workers actively working per car length at a time. At Tesla, there were often 10 or more simultaneous workers per car length, and shorter car length too, sometimes more than 20, meaning the factory density at this stage in Ford's plant is, as of this video, very low, possibly 10% or less of Tesla's factory density, the actual work being done per car length. Also, we aren't seeing unit testing on the line during assembly. All screens are dark. We're not seeing factory mode. By all screens are dark, I mean inside the vehicle. We don't see any screens light up until after final assembly and after inspection. We're not seeing the vehicles self-test themselves at the unit level or integration level during the build, which enables the rate of change as we're building, the agile manufacturing. I may have missed the cue point where it shows the chassis closer up. I wasn't able to tell if there's foam fill or not inside the ladder frame chassis from the angles seen here, which can increase impact safety, add structural rigidity. You can use a thinner ladder frame, even if you're using traditional ladder frame. It also can help with noise, vibration, harshness, and even anti-corrosion. But I didn't see it. What I do see is integrated venting for thermal runaway events, mitigation, really management of thermal runaway events, helping cope with the horrible catastrophe if the battery pack ever ignites. That's actually super intelligent. It looked like there were many thermal vents on all sides of the frame. Yeah, again, the smart carts appear to not be dynamically called. It looks like they're on fixed tracks. Again, not roboticized, it's manual lifting aids. The screens are dark. We're not seeing testing running during assembly yet. This is also very early on. This looks like Ford's production hell. And likely it will continue to improve as long as the pace of innovation during assembly is allowed, and it's not a single funded operation of now the assembly line's done, there's no funds left to improve. And I don't know the budgeting financial strategy for the Lightning. It's good to see the known stable interfaces on the carts. Pardon the ad. But again, it looks like they're all on fixed tracks. Let's move this to 1.25. It's okay, 1.5. Body integration is automated. That's actually a big deal. Here comes that same pack we saw at the beginning. So you see the known stable interface delivering the robotic pack. Here is where I don't see any evidence of foam, but it sure looks like these are thermal runaway vents for the battery pack, all up and down the length of the frame. Very intelligent on Ford's part to integrate those directly. Again, awesome automated integration testing, which could allow a faster pace of change at this step, if this is what Ford chooses to do. Now this is awesome. This is automated coordinate measuring system, checking the interface points automatically. And at this point in manufacturing, it looks like they're checking every single truck. I hope that continues. That is a fantastic trend. It means the interface could, in theory, change. And this automated step in the align could verify the change, and which would absolutely reduce the time to change over from one interface to another. Instead of a holiday season-long shutdown, it could be potentially one overnight shift. Again, automated marriage steps, that's good. In this case, there is a manual roll inside. Hopefully that gets replaced by a set of cameras and some machine learning. Interesting, I don't see any evidence. It may have been edited out, but in this video, I don't see any evidence of machine learning augmenting the production workforce. No digital self-management. The robots all look like they have fixed end effectors, fixed hands. That means they're optimized to do the same operation again and again and again, which means if you change the car, you have to change the robot hands instead of flexible end effectors, flexible hands. Now this one is especially interesting. This Kamau robot, it's their Aura line. This is a cobot, a robot that's meant to safely work with humans without having to shut off the robot before you enter the robot's cage. I believe that's because there's no autopilot being used. There's no self-driving being used in the factory. It looks like there's a human driver, which we'll see more clearly in a future frame, even at this step. Now, what's cool is the truck is being driven inside the factory. They're getting some testing feedback already. The downside is it appears to not be automated, which means at this step, they have to pay way more for a cobot, a robot that is deemed safe to work with humans in the loop. Now, what's very interesting to me is a human drives the car up and this cobot does something to the bed of the truck that compresses the shocks. Now the charge port's on the front left. So what's going on in here? See the shocks compress. I actually would like to know what that step is, but it's an unfortunate necessity because there's a human driver. The vehicles are not driving themselves. Now here's the inspection line, and this is full of machine learning in Tesla, which is the DSM video as you saw. At least in this video, we're not seeing it, but to be completely fair, in all of Tesla's earlier videos, they edited it out. It was removed from all video clips, even like digitally edited out in some cases. So Ford very well may have this area packed with machine learning, and it could be fantastically advanced, but we're not seeing it in this video. We're seeing traditional, manual, not self-driving inspection. Yeah, you can see the human drivers through the inspection line as opposed to autonomy here. So cool, the vehicles are under their own power. They're getting valid inspection, but they're not doing it themselves. Now here you can see there's 6 rows wide of exits. That lets us know the at least near-term planned capacity, except the entire production line isn't 6 rows wide, actually only this step. So I wanted to say, look, there's 6 rows width of production capacity. We can use that to forecast near-term possible exits. But unfortunately, when the camera swung around, we could see these actually bottleneck into a single line. It does look like there's a single one-piece continuous flow traditional manufacturing model, which means you can't have, at least not in this floor plan, parallel innovation at the same time as production, and then branch in new models once they pass test like Tesla does. They don't have an agile line configuration as far as we can see here. Absolutely fantastic work by Ford. I'm very impressed at the pack size, the future planning, the repeatable hard points on the pack. I'm excited by the automated testing in very key areas like pack integration, and body marriage, and body on frame marriage. However, there's tremendous optimizations in terms of agile manufacturing. The wiring harnesses are not yet rigid. I'm not seeing any digital self-management to empower the workforce to make design decisions on the line. I'm not seeing any design on the line or near the line. As far as I know, it's a separate office building somewhere else, and it's released on a 1 year or less cadence. And that means when there's a problem in design or we have to switch suppliers, it's probably a multi-week shutdown. It looks very traditional manufacturing, but with a massive battery pack and some automated testing. So absolutely kudos. This is probably the most advanced Ford product ever made. And I think it bodes well for electric pickups. I don't see it in the same light year as Tesla's manufacturing process in terms of pace of innovation. Thanks so much, Joe Justice, former Tesla employees. Kudos, Ford. If you continue to ramp the innovation, Ford, I'm really excited to see what this product can be. Have a great day, everybody.